Good morning. Today, for a little bit, we're gonna be doing some coding. Alright, just one sec. Just some coding today. Some people. All right. So, what are we coding today? Well, this is in C# Monogame. This is what Switch Ball Deluxe is built off of. So if you've seen any recordings, the previous streams, we're doing a lot of playtesting recently, a lot of level creation, but there are some bugs that I want to work through, and there's also some really big features we could get started on, and there's also smaller features that are going to need to get integrated anyway. So we'll just be doing some stuff like that this week, trying to get some stuff stored away and also work on some new things. And part of that's just coding. So you're gonna see a lot of this. So if you want to see how coding works and how my mind works a little bit and how I tackle problem solving, this is for you. If not, it's all right. Click away. So what we got on our task to do. So this is kind of what I have thus far. There's a lot of small fixes. Some of them are art fixes. I just do stuff in Excel. It's easy. I've used other programs in the past, like Trello and different task management suites. All that is great if you have like a team of people working on it. If it's just you, keep it simple. Don't use external software that just complicates things. Sometimes you like it if you can like track stuff in the past for like project management. If you want to see, oh, when did I get stuff done? Sure. But in general, if you're working by yourself, just do what's easiest for you. So some features here. We can actually mark some of these as a feature or a bug. I didn't really do that over here. I think in the left column I had one. Yeah. So I have dev and bug. I even have these priorities and points. Right now these don't really matter. Let's hide these columns. So let's instead change these to feature and bug. So fanfare, that's definitely a feature. We don't have that yet. We have a fanfare whenever you beat a level, but this is like whenever you complete a world, there'll be some fanfare. So whether it be like a cutscene with a menu or something like that. One line iOS or phone implementation. So I'm gonna put iOS phone / tablet. That is way too big for a feature for just one line, but that's fine. In options, have a way to clear all the save data. So right now, this would require two things. Right now, save data is actually not being stored where it will be in the final version of the game. There needs to be some tweaks about that. At least level data isn't. I think save data is. But in any case, this is a new feature. This has been mostly fixed. This was actually a feature and a bug. So I'm going to put feature bug. Sometimes you clip through a brick. That's a bug. Good. Nothing's highlighted. That's a bug. That's a bug. If you use clear, the text goes away. Bug. Bug. Various art updates. That's very helpful. This is a feature. It's a feature. Okay, so the first thing that I want to fix is we've already worked on this. There was a lot of art. There was a day or two where we were fixing explosions that were a combo of 8 or larger. And I completely refactored the sprite sheet. I had to create a new sprite sheet. So what we're going to do is do the second part that says if we have a combo 10 is the max, then it says max combo. So we need to make something that says max combo instead of 10 and then enforces that. We've proven in game that it's basically impossible to get a combo of 11 or greater based on the play area. But rather than just say, well, theoretically it's impossible, let's actually implement something. So we'll do this first. This should be a pretty easy one to do. In terms of branches right here, I haven't switched branches in a long time. This is also not good. Every time you do a new feature or bug, you have to change branches, have stuff. Everything is in Git and stuff, but in a private repo. I've been working off of the same branch for a while. Probably off stream, I'll start switching branches as we do more fixes and updates. So what we want to do here, what's the game plan? Well, the game plan is we want to see where does combo get triggered, and then where do we display combo? So it's both where does it get triggered, and then how is it displayed, and those are the things we're going to need to update. So wherever it's displayed, we can do that first, is right on the screen. I believe it's the hood. It's either the hood or the level. I think it's the hood. So we're just going to open up the hood. We're actually going to close everything here. And we'll open up the hood. Now the hood has a whole ton of stuff. If you were making a new game, you could create your hood. You could split it into multiple pieces, like make it a little bit modular. Mine's just one behemoth. So what we're going to do is we can actually just look for combo. Combo. We got a bunch. This is about points and stuff. There was a point in time where I was doing points instead of just time. Wasn't exactly sure what I wanted to do. I think this is it. Sure. Level name, almost. Oh, here it is. So we have a Boolean because when you get a combo, it shows the combo level for a period of time. And it also moves the text up briefly. So there's also an update for show combo level up, where it's kind of moving this combo level up position, because for a brief period of time it moves it up, and it's a little bit what's it called? Stylistic? I don't know. It's like a whoop. So here, this is where we're displaying it. So all we need to do is we're doing combo level plus, and we just get the combo level to string. Now if we go over here to the combo level, we can, in the player class, go down to where that is being used. And you can see here, trigger increase combo level. So if I go to that method, what this is doing isn't actually changing the combo level. That's happening around here. You see combo set, combo points and stuff. All this stuff is related to the hood. You can see that in the player class, it's actually doing stuff. This could be in the hood, like the player class could call these methods in the hood, Right now, I'm just putting it in the player class, but there's different ways of organizing it. So here, when you're increasing the combo, what it's doing is it's resetting this boolean to be true. It's setting the position of the words and the opacity. So all this is setting the position of what's going to display on screen. When you're setting the points, it's doing this. It's saying, hey, this is how many points it is. Show the points going up. And again, this was when we had points. So points was something that we had before. We just didn't have level. We would try to get some amount of points. So this isn't being called anymore, but you can see there's a lot of different ways to easily refer to different classes. And same for combo broken. So we can actually click back, because this is actually here. So here you can see that arbitrarily the combo is allowed to go up to, it just increases. Now when the level is completed, the combo gets reset to 0. Or if the combo is broken, the combo gets reset to 0. So you can see here, if the combo is greater than 0, combo is broken, it resets the combo attributes, and here is doing a lot of stuff, like setting the combo to 0, the combo level to 0, showing that you're shocked. It might change the color. So what we want to do is we just want to make sure that the maximum is 10. Now you could have a method for this, or you could do it in here itself. So because we have something called trigger combo broken, why don't we create a new method called increase combo, and all it will do is increase it just like this, but just have a guard to say it can't go higher than 10. So we'll just go to this method. Nope, that's not the one I wanted. This one. I guess these are all around. This is around resets, I think. Yeah, just 1 second. Un momento, por favor. Okay. Cool. So, Smoky Joe. Yeah, here are all their combo stuff. So we're going to just do a very simple method. This is a void because we're just going to update the existing variable. We're going to say increase combo. And here, I'm going to say if combo level is less than 10, combo. Literally that simple. So all we want to say is saying, hey, if you're not yet at 10, go up. Go back. And then whenever we see combo plus plus, we can just put in our new method. And we can check to see do we combo plus plus anywhere else. Oh, that's the combo. I already messed up. This is the combo level plus plus, not the combo. We need to go back. This goes here. Now you could have something like here, all of this stuff is displaying like a menu effect if you increase your combo. So here we also want to say if combo this, and combo level is less than 10. Now this is going to be a little bit redundant because increased combo is also going to be checking this. But since this could theoretically be called outside of this if check, we'll just leave it like that. So we're going to go to the other one, and we'll just do this. So now the combo can't go up if it's more than 10, and that's something we can check using the level editor in a bit. We also want to make sure that it's showing correctly. So what we want to show is instead of combo level 10, we want to say max combo. So what we're going to do here is say their combo text. And what we can do is say if our combo level is less than 10, then, so it's an if-then statement, and you can do it shorthand like this, and you have it like this. Some people do it like this, so you can see it line to line. Else, I'll just say max combo. Max level, max combo. Something like that. And you can just put that in here instead. So now in one line, you're basically saying if you're less than 10, keep doing what we've always been doing. Otherwise, say max. So there are the updates. We have our text update here. We created a very simple check here for the combo. And I think that's it. So now we can try it out. Now we actually, because we have every single level in the game made, even though some will be updated, I'm just gonna turn that down. We don't have any like test levels that we can just mess with. So as long as we're not going to save anything. We can basically choose any level as long as we don't save anything. So I'm just going to choose the first level. So in order to test this, we just need enough bricks to make our level arbitrarily high. And then once we're out of bricks, we'll just add more, basically. Create a nice little line in there. And what we want to see is that once we get to 10, you can't get any higher, and that max is only triggered one time. So if we get up 7. Alright, so at this point, what we can do is I can just turn on this and just add more. Uh-oh. No, we're running out of time. I forgot about that. No, 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 no. Alright, I should not have chosen the first level. It was only 35 seconds long. We had to choose a later level. One of them that has an infinite time. Here we go. My bad. Again, we're not going to save so we don't lose this. Or overwrite it at least. You can always retrieve it again. This is a much later level. Okay. Get these things out of the way. Alright, we're gonna have to try that again. Oh, we still have one. It's hiding. Sneaky. Create some gaps. Gaps is allow you to ping pong. Okay. Good enough. Alright, so here we go. So we're just gonna get up to here. Up. Alright, so we're at 8. So now we just go over here and we're gonna add some more to get to them. So when they explode, they actually leave a remnant behind. You can see the animation's a lot of sync too. It's pretty great. Alright, so now we can take out these. We're at 9. Just gonna say max. There you go, max combo. Beautiful. Okay, so now we will do this. Okay, so theoretically, it won't say anything again. Alright, perfect. So it's not increasing the size, it's not saying anything again. And I think we did it. Easy peasy. Good enough. One test. Okay. So we're just gonna say done. Done. All caps. Done. Alright, next up. We can highlight, this one is real big. So there's some big features. Usually features at this point in the development process are not trivial. Some stuff is actually not going to be that hard. It's all about planning, such as like a tutorial. Depending on the type of tutorial, it could be really like a big feature, or it could just be like, oh, you're actually creating like a video or something you're showing one time. It's not that big a deal. So I have an idea of what a tutorial is going to be, but that's not something I want to start right now. So I think the next step, let's try to fix one of these bugs. So let's take a look at this level. It says on level 50, I was able to clip out of bounds at the top. I have an idea of why that would happen. But let's take a look at that, and maybe we could possibly just change the level design so this doesn't happen. Because changing the way that things clip right now is something we probably will need to address at some point. But it is a much bigger thing, so let's just take a look at 50. And see if that, if there's something we can tweak there for the time being. Minimize VS. I'm gonna go to 50 barriers. Okay, I know how you can clip out. And I will clip out of bounds really quick just to show you. So if we go in between here and we're at the top, we do this. Right. Or maybe at the bottom. I think you have to be holding down. There it is. We're out. We did it. Now you could always restart the level, you know. There used to be a game over screen for this. If you do that. Now, why does that work? So clipping is something that I implemented for this specific reason, for moving blocks. So you can see if I'm the wrong color, when it clips you through a block, it squishes you. What it's doing is it's saying, hey, if you are on the edges of the level, push you towards the middle of the level. So you can see I'm at the top, it's pushing me towards the middle. And what it's doing is it's finding the next open space for me to do that. So for example, here, you can see I'm at the top, and I'll just pause buffer. And eventually I'll get squooshed. And you can see in this frame, we still have the animation showing behind me. But I instantly, poof, am in the closest spot in the middle of the screen. And then it'll happen again. I get squished. It says, hey, you are on this part, so go towards the middle. Similarly, if I was like on this edge, it's looking to basically see, am I above or below the middle of the screen? The same goes if I was squished horizontally. If I was on the left side of the screen here, it would push me to the right. If I'm on the right side of the screen, it's pushing me to the left. So everything's trying to push you towards the middle of the screen. You can see down here, push towards the middle. And even the clipping doesn't always work just because you're pushed. Sometimes it has to do with momentum. So you saw there, I was attempting to move into the same spot that a brick was moving towards me. So because they occupied the same space, I clipped through. And this is a perfect level to show that. Now, how do you get out? Well, occasionally, if you're clipping multiple times, it's going to say, all right, can you clip up? No. Can you clip down? Yes. Can you clip up? No. And it'll keep ping-ponging until it finds an open space. Now, on the edges of this area are basically invisible blocks. So invisible blocks act in the same way, where if you're trying to go through an invisible block, it's not going to let you sit there and be stuck forever. So it'll just go through the invisible barrier too, and then you'll be out of bounds. So we can try to get in there to the right here. And I think if we do it right and get in between these. Now, if I'm not holding down turbo, which increases my speed, there's a less of a chance that I'm going to clip through because my speed is also taken into account for the clip. If I hold down turbo here and make it so that all the blocks are aligning and there's no gap to go through, I can sometimes get out, depending on the position. It's not super reproducible here, but what I can do is if we really want to test it, we can just add more blocks that are moving. So I'm just going to add more that are moving here. It's sort of shaking because every time I add one, it's resetting. But again, we're not going to save this. Alright, so let's see if this works. There we go. Pretty quick. So what's the solution for this? Well, you gotta fix how clipping works. So, one, you could change the way that levels work. Because this is a level-based game, if something is breaking the way that the code works, you could be like, well, let's just create an instance where that never happens. So that's kind of the soft way of fixing it. The more code-based and more rigorous way of fixing it is making sure that in all cases, clipping is not going to send you out of bounds. And what's interesting is thinking even about how different games treat out of bounds. Some games, there's nothing. Like eventually there's a barrier that will reset you to a certain position. Like if you think about an adventure game, say Donkey Kong 64 or Legend of Zelda or Skyrim or any of these, there could be a death barrier. There could be an out of bounds barrier. You see here there is a death barrier outside of the whole screen. So I could just reinforce that and just say, hey, on death, you just say you lose. And I think I actually did have that at some point. But in this sort of game where that's not really a thing, we probably want something better to just say, hey, if you are outside of these bounds, put you inside these bounds. So let's take a look at where it is clipping us and where it's enforcing that thing that I said that is trying to push us this way. And probably just add a couple lines of code that say if you're not within this space, put you within this space as close as possible to where you exited that space. So let's go ahead and look at where this is happening. So where would this be happening? Let's see. I'm going to zoom in even further for you guys. I think it's going to be happening here. So this is the collision box. This is what's called an impenetrable collision box. One that can't move through another one. I think there's one called clip something. Unclip. Here we go. This is a method that I made myself. So it is somewhat flawed. Essentially, when I try to unclip, I try to go in different directions. But I think I modified this for this game. This was, yeah, I changed it. It used to work this way, where you would look in different directions. But now it does something different. Because this is a code base that's based off of an action platformer. So before, there would be a lot of 2D movement, where you're jumping around in things and you could be clipping all over the place. And basically you just wanted to get yourself outside and not stuck. here, you just want yourself to remain in that center box, the play area. So instead of doing all this left-right stuff, you can see it says, hey, we're not being used right now. What it's doing is, it is doing this. And let's see what this is doing. I want to make sure nothing else is happening. Yeah. So it is doing a while loop. And what are the boxes that it's looking through in the while loop? Boxes it's sending through. Okay, what boxes are you clipping through? So there's a set of boxes that's passed in here. These are basically the surrounding boxes for the clip. And we have our original position, which is the position we came in with to the clip. We also have our invisible boxes, which are the border of the level. I'm actually not sure if these are being used. Doesn't look like it, no. I think these are being included in boxes if they exist. We have exit collision, which is important because, hey, this is only going to get out when we say we've exited the collision. So here we're saying, hey, if at any point in time our boundary is no longer intersecting the boxes that we came in, we have now exited the collision state and we're out of the while loop. Here are our hard-coded values. So there's nothing in the game right now where you're actually moving to a different part of the level. There was something at one point where I considered having some of that classic 2D platforming screen moving and the level actually being bigger than it is. But for the scope of this game, it's actually just going to be static. That's what you're looking at. Which is a lot of puzzle games, right? You're just looking at that static screen. I guess a lot of modern ones, there's more movement, but in any case, these are the original positions. So we're saying, hey, if we came in here, and this is what I was saying, if you were on the left side of the screen or the right side of the screen, I'm just telling you, hey, if you're in the left, go right. If you're on the right, go left. If you're on the bottom, go up or go down. And if you're on the bottom, go up. These look a little bit odd, and that's mainly because in Monogame and in a lot of video game geometry, the Y value is actually positive as you go down, and it's negative as you go up. It's the opposite of what in standard geometry. But the X is also positive to the right, negative to the left. It's just the way that geometry works in game. So our movement here is saying, well, how is the ball moving? Because the ball is always moving. And it's saying, hey, is the rotation happening? So the rotation is, hey, are you moving left, right, like this, or up, down? By default, you're moving up, down like this, but if it's being rotated, you're moving left, right. So it's saying, hey, is our movement X? Which way is this going? So it's saying, hey, if we're rotated, it's setting this speed of 2. If you're going left, it's setting it to -2. And in the Y value, it says, hey, if it's not rotated, going down has a speed of 3. Going up has a speed of -3. Now, this movement XY is basically the like every single time it attempts to go out, it's going to keep moving that many pixels, or that many units. We'll call them units. I guess they're pixels, but really that many units to the right or left or up or down in order to escape the blocks that it's intersecting with. So here it's saying, hey, our boundary, let's go ahead and keep moving that amount X or Y. And we're going to keep resetting our boundary to that new boundary. Eventually, that is going to escape out of our boxes that we were colliding with at the beginning, and we'll get out. We're never actually changing here. You can see we're never actually changing whether we're going left or right. Because our original position is what's determining whether we're going right or left. So, all these things being said, how then do we make sure that we are not escaping the boundaries? And how is it even happening that we are escaping? Well, it's happening if you have a column of blocks or a row of blocks such that if you start moving up, if it says like, hey, go up, and you just keep going up and you never actually stop hitting a block. Eventually you'll just keep going up and up and up and up, and the only time you escape is when you actually get out of that invisible row of blocks and you're outside of bounds. You go up, you hit the camera on the edge of the screen, and you're donezo. Same if you went down or left or right. If there was never actually an empty space within the play area, you'll just keep moving until you find the empty spaces on the outer edges, and you're donezo. So there's a couple options. Option one is just making sure that the ball stays within that area. It's pretty simple, at least in theory. Option two is allowing it to happen. Oh, excuse me. You'd allow it to happen if you didn't care about there being a death screen. I think the death screen's intuitive is not intuitive. It's not intuitive in this type of game, because this is a puzzle game. The only way that you lose a level is if you run out of time. So having something where it just says and you're outside of the screen, someone who has seen that, like, what just happened? What? This is a game-breaking glitch. Oh my gosh. It's like, no, you just sort of clipped out. So we don't want the player to see that. So what we want to do here is just say, hey, if your boundary is ever outside of these parameters, you have to go the other way. And how will that work? Well, if you keep going up, there's never going to be a point in time in any of the levels, and again, this is contextual, where if you get clipped, it will forever be a full line of blocks straight up and down, or a full line of blocks left and right. There will always eventually be a space that you can move. It just might be below you now if you're going up, and it might be to the left or right of you if you're going that way. So that's what we want to do, is we want to check your position and say if you're at any point your position is outside of a rectangle, go the other way than you started. So that's kind of going to be the way that I'm going to tackle this. So first we need to get the rectangle. So we have our position here. But what we want to get is that rectangle of play area. Which I'm pretty sure I have set up in the hood. It's actually really easy for us to see in game though, so I'm just going to start the game. Show it that way. Let's do this quick. So here we can turn on the grid. And you can see this is the rectangle that starts the edge of our play area. So this is our rectangle of space. And we can just write down some coordinates here for fun. So you can see that it is a 16 by 16. You can go to the bottom. The bottom though is a little bit off. That's intentional. So, what's our play area? Let me get out a little notepad to write this down. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 over, and 1, 2, 3, 4, 5, 6 down in order to get to this spot. So it's 8 times 16 over, and then 6 by 16 down. And then the actual play area is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, I miscounted. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Oh, we did it! 24 wide. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14 tall. And because we know the origin here is 0, 0, we centered all this at 0, 0 on the top left corner. So, if we go back here, we're going to set our rectangle. Let's put it here. Say our var rectangle play area. Let's say a new rectangle. And we'll set this in a second. So we just said that the X position, do you know why I did this? Because in SQL Server, that's a comment. And I use a lot of that in my job. So our X is 8 blocks. Each of them are 16 pixels. So our X position of it is 48 plus 80 is 128. Our Y position is 6 times 16, which is 96. So the rectangle's X and Y position here are going to be 128, 96. And then the width of the rectangle is 24 long, so 24 times 16. And then the height is 14 long, so it's 14 times 16. So 24 times 16 is a number that I don't feel like doing in my head. 24 times 16, 384. Now you might ask, hey, how do you not know this offhand? It's like, well, it usually doesn't come up that much. In the play area, 224. So then it's 384 wide and 224 tall. So this is how big our rectangle is and where it's positioned. So what we want to say is, if we are ever outside of this rectangle, if our position of our ball ever moves outside of this, we need to go in the opposite direction. So what we're going to do is this, is say this. We'll do it and in fact, all of this stuff is based off of the original position, which is not changing. So we're actually going to move this here. And this is the exit collision. So always want to check that first. So we're going to say if object box dot boundary intersects rectangle play area, and we say if there is some point we are not intersecting that, that means we have clipped outside of bounds, and uh-oh. So if this ever happens, this is where we're going to switch directions. So we're going to say if we are going right, I would go right. If we're going right, then go left. I'm going to say go, actually do this. So we're going to swap a doodle. And if you're going left, then you're going to do the opposite. And then the same for up and down. So if you're going up, you're no longer going up, you're going down. And if we're going down, you're now going up. Okay. Now this should work. There shouldn't be like an infinite left, right, left, right, left, right, left, right. Because the moment that we are no longer intersecting this, we're going to turn around, it's going to flip, and we're going to go a few pixels back. And because we're going the same distance back that we just would have left, I don't think we are going to have an infinite loop here of going flipping back and forth, back and forth, back and forth. But now we're ready to test it. We have a rectangle. And theoretically, we will not escape. So let's try it out. Wait, did I put that on the... Is that on the to-do? It's been like that forever. No? Oh my gosh. Bug/feature. Fix options menu. We'll put more details later. How have I not written that down? I thought I'd written that down a million times. Okay, so to add more of these, to make sure we clip, we're just going to add more here. And once it starts moving, it'll be fine. Oh, I forgot to put them on the track. So now... Try it again. It didn't work. Interesting. Oh, now it's even worse. Why? Wait. do wrong? Alright, we need to pause. Alright. So we go down here. Going like this. Where'd we go? Whoa! Why are we way up here? No. I messed up. It's not working. We need to set a breakpoint in our code. Let's wait. Let's finish this. Let's go back. Okay. So we're gonna have to set a breakpoint. I don't know, somewhere in here. Okay. There we go. So, theoretically, you can see here, it should be sending us down. Oh, wait a second. Oh! I see. So it's supposed to send us down, right? And now we're going down, we go back up. Who saw that? We need a method. Reverse directions or something like that. I don't know, bro. Is this the edge of the thing? Yeah. Public. Reverse directions of clip. Put that in here. Let's put it in here. Take this and go down here, and we'll just say if you do it, then return. What? Oh no. These are local variables. We declared them right here. Control Z, Control Z, Control Z. Bah, bah, bah. Z, 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 Z. Z is easy. Okay. I think this needs to be else. That's fine. There we go. That's all we needed to do. So just immediately turn directions. Okay. Me smart. Me smart game developer. Me make video game. He's so good. Alright, try again. Okay. There we go. Get in there. Alright, went to the bottom. I'd love to see it. Uh-huh. It's finding its space. Beautiful. Look at that. All right. So now we're going to restart the level. We're going to put more out. Okay. So technically, if you look, there's always a space other than right there. There's like a moment where there's not a space. So I'll be interested to see what happens here. Because there is a moment where there's no space when you get clipped. Let's see what happens. Didn't work. Alright, what if there's just a little bit of space? What about like this? See, there's one. There's always some space. Alright, what about now? Gosh darn it. Alright, the good thing. Alright. Good news and bad news. Good news is that it doesn't break what we already did. That was bad. Why didn't it trigger? Alright, let's try this again. What's up, stage 4 boss? We're trying to fix clipping. We're coding today. Today is a coding day. We're clipping out of bounds continually. It didn't even hit it. Why? Why not? What? Why did it hit our breakpoint? Alright, has our solution built? Have we been dealing with the same thing? If object box is not intersecting with this, It should have done the thing. Alright, we're gonna do that. Yeah, we got some Toon Skis playing today. Try that again. Zoop. Alright, that should hit our break point. Alright, we're in here. Go right! Wait, no. wait. What are we gonna do? Go right is true? Huh? Why? Oh! Oh, it's trying to do both. But we're not being clipped that way. Alright. I got our fix. We got it. We got it, chat. So, right and left can only happen one time. Up and down can only happen one time. You can do both right and up and down. All we gotta do is this. Da-da-da-da! Alright, this is a quaz guarantee. This will work now. No more clipping out of bounds. Guarantee. No more. Here it is. Set up the clip. That's the this fix has been one story point. All right, here we go. Wait, let me get in there. All right. Oh, it went to the bottom. We did it. Wait. I'm in an infinite loop. Game froze. Uh-oh. Uh-oh. What's happening? Yeah, that's how the clip works. Oh. Wait a second. I'm no longer intersecting the play area. Where's my boundary? But we never exited the collision. Wait, where am I? 277, 103. 277, 103. Wait. Yeah, so if you clip to the top, you're supposed to go all the way until you find an empty space to clip through. So right now, we are intersecting the rectangle play area. So what is our go right is true, go left is false, go up is true, go down is false. Okay. So go right is true. So our new boundary, 277.97. So if we just let this go for a little bit, 277, 142. Wait for a little bit. $277, 211. So we're gonna go in here at some point, right? Yeah. Because now we're outside of the play area. Because we've gone too far. And now it's gonna try to go up. That's interesting. So what's happening at this point in time is it's attempting to go up and find an empty spot to live. I thought it would get into this little crevice right here. But what's happening is it goes up, it finds that there's nowhere for it to live in this column that is within this play area. So then it goes back down again, finds there's no one, and it's just ping-ponging back up and down, up and down, up and down, never finding a place to clip out. I thought because it's also clipping left and right, it should have clipped out to the right or left of this at some point, but it's not. Why is the right left not working? Oh, because it's only doing it if that's true. So right now, rotate gravity and controls is false. So it's not doing the right or left clipping. If you're not inherently moving left or right. Alright, this has turned into a 2-story point fix. Alright, the good thing is the code's working. The bad thing is you can get stuck. In some circumstances. So... how do I want to fix this? You could make it such that if you did a whole cycle of up and down, so say you tried to go all the way up and you failed, and you tried to come all the way down and you failed, then it can be like, you tried, bro. Now let's try left and right. That seems to make sense to me. It's like we attempted to do a clip up and failed. We attempted to do a clip down and failed. Now let's try to clip left and right. But in order to clip left and right, you would have to do it at different gradations of up and down. So... I don't know. That's interesting. I'm gonna have to think on this one. Yeah, I could do it. I can talk through it one more time. Let me just show the game, because I'm not going to be able to figure this out in the next 10 minutes. I'll explain it one more time, and then tomorrow I think we're going to have to try to figure it out. Alright, so what we got going on here, one more time, is I'll show up the level in question. Granted, this could happen with any level, theoretically, that is moving bricks. And we'll just go ahead and add some of these. So this is a simple level called barriers, where you're supposed to get the different colors, and you go through the barriers, and you go back and forth. So the way that clipping works in this game is if you're moving up and down like this, it's going to attempt to clip you up and down. If you're moving left and right, which is when you have a rotation brick like this, it's going to attempt to clip you left and right. So clipping left and right if you're going left and right, clipping up and down if you're going up and down. Now, when it attempts to clip you, one of the first updates that we did to enhance the clipping functionality is staying within the play area. We do not want you to get outside of bounds of the play area. If I press, I think L. Oh, I don't have this on. Whoa! Don't do that. There are invisible bricks or platforms all around this area where like the pipe is. So that's how you're staying in bounds here. Now, if you get hit and clipped, I'm going to remove this. It's going to attempt to find an open space to move you up or down that is towards the middle of the screen. So here, it's going to always attempt to move you towards the middle of the screen if possible. This works if you have any open space. The problem that we're running into is when we have no open space. So just to test the limits of the clipping, what I did on the right was I created a line of bricks that you could clip through, and when you do, there will be no open space in the top and bottom to move to. That's the problem. So the solution is to say at some point, if you're getting clipped and you have no open space within the play area, what we need to do is start clipping you left and right in order to find open space. And try to make it seem so you're not completely somewhere unexpected. These sorts of clips happen a lot with the hydro mechanic, because either you get stuck. There's like a few different ways you can do movement, especially when you're moving automatically, because that's the way that Switch Ball works. I mean, there is speedrun tech that will use clips, yes. You could either have it move you, kind of like if you're being moved by a train like that. That's sometimes how movement works, of course, in games. You either clip through, so in this case, that's what's happening. We're both attempting to exist in the same coordinate. That's not allowed to happen. So you are going to move somewhere where you can continue moving. Very common in NES games, and in most games, is it doesn't allow that to happen. Sometimes in games, it's so severe that it says like you need to void out. So if you ever get clipped, you immediately void out and you get reset to a position. Here, I just want to get it so you can continue playing. But we can trigger the game crash again, or at least the game freeze, by just going here. And if we time it right, I think. There you go. It worked. So it's not too hard of a fix. Basically, at some point here, if we get stuck in a loop, we're going to probably choose like the midpoint of the screen. And then once we find the midpoint, we can clip it out. Or maybe we find something that's just above or below where we are and keep looking left to right, left, right, left, right, left, right, left, right, and find open space somewhere within the play area to clip out. But that's for tomorrow. We got most of the way there, and did a little other feature too with combos. So just a little bit each day. Little bit each day. Make the game work. Is there ever a state where there's not an open space? No, that is not a thing. That means this whole play area would have to be completely full of stuff. So, um, no, that will not be a possibility. That's a good question. In the horizontal V column, so theoretically, yes, but then you would just keep moving up. So you could like move here, and you just keep doing checks horizontally as you move vertically. And you could choose to like move a little bit up and then do down, or you could go a little left and then right. So you're sort of scanning. You're almost doing like a grid scan for possible locations that are near where you are. Where horizontal and vertical moving platforms intersect, that'll just be another place where you're intersecting with a thing. So regardless of how those are intersecting, then you just have more platforms that are potentially in your way. Generally, it'll happen like instantaneously because there's so much open space in every level that it's pretty instantaneous. So I think once we at least get it so you can't clip out of bounds, the clipping might feel weird. So there might be ways that we need to improve the clipping so it just doesn't feel so awkward. But you at least won't get to a state where you're unintentionally going out of bounds. But that's going to be it for today. Thanks for all the questions. Rubber ducky emote, yeah. For sure. But tomorrow we'll be back at it for a little bit. And keep working on coding. This is a coding week. Ooh. So this is a week of bug fixes and coding, feature development. So I will see y'all tomorrow. Thanks for all to check this out later on YouTube and Twitch for those who like to see how games are made. As always, love you guys. Jesus loves you too. I'll catch you next time.